Okay, so we're going to finish off today by solving simultaneous equations using matrices. So in year 10, we've solved simultaneous using either substitution or elimination, but now we've given you a third option. We can solve it using matrix methods. So suppose in example 11, we have two simultaneous equations, 4x plus 5y equals 6 and 3x plus 2y equals 8. Two unknowns, x and y, two equations is all we need to solve it. However many unknowns is however many equations you need to solve for your unknowns. So we've got 4x plus 5y equals 6. And I'm going to write the second equation right underneath it. Make sure to stack the x's on the same column and the y's in the same column. So 3x and 2y equals 8. So I'm going to turn these into matrices by letting my A matrix be the matrix of coefficients of my x and y's. So you can kind of see how this itself is a matrix feel, and then the 6 and the 8 is like a column matrix as well. So my A is going to be a 2 by 2 matrix because I've got 4 coefficients like that. B is going to be my column matrix. Sorry, no, not B. X is going to be my column matrix of variables. X because I'm trying to find the unknowns, x and y, okay? And lastly, B is going to be my matrix of what the equations equal to, those values there. So B will be 6 and 8 as a column matrix. Now, I can say, now that we've defined A, X, and B like that, that A times X equals B. Do you agree? Well, if you go row by column, so 4x plus 5y equals 6, and that's our first equation. And then row 2 by column, 3x plus 2y gives me 8, and that's my second equation. So turning my coefficients into a matrix, my variables into a column matrix, because I've got two variables, and then my whatever the equation's equal to, those values to be my third column matrix. There you go. We can have a matrix equation, AX equals B, and we can easily solve AX equals B using A inverse and identities, right? So let's go through the process. Well, my A is on the left, so I need to multiply both sides by A inverse on the left. So that's equal to A inverse B. So A inverse times A gives you identity, because that's a definition of inverse. Identity times anything is itself. So X is A inverse B. So that tells us we need to work out the A inverse first. So default formula. So A inverse is AD minus BC. Swap your A's and your D's and negate your B's and C's. Right, so since our A is 4, 3, 5, 2, our A inverse is 1 over 4 times 2 minus 5 times 3. Swap my A's and D's, so 2 and 4 swap, negative the other numbers, so negative 5, negative 3. So 1 over 8 minus 15, and I have 2, negative 5, negative 3, 4. 8 take 15 is a negative 7. 2, negative 5, negative 3, 4. Okay, so that's A inverse. Now to work out X, X is A inverse B. So that's 1 over negative 7. 2, negative 3, negative 5, 4 times B, which is my column matrix of 6 and 8. Okay, quick dimension check. This is a 2 by 2. This is a 2 by 1. Inside numbers match up. So yes, we can go ahead and multiply it. So X is equal to 1 over negative 7. So I'm expecting a 2 by 1 answer. Okay, row by column. So 2 times 6 is 12. And 5 and 8 is negative 40. So 40, that gives me what? Negative 28. Next we have a negative 18 and 32, so that's a 14. So X is equal to, I'm going to multiply the coefficient in. So 28 divided by 7 is 4 and the negatives cancel. And 14 divided by 7 is negative 2. Now, since x, out of space, I've squeezed in here. So since the X matrix is X and Y as a column matrix, right? So we agree that two matrices are the same if they have the same dimensions, and therefore the elements are the same. So therefore X equals 4 and Y equals -2. On an exam, the easiest way to check your answers is to check via substitution. So if I subbed, let's label this equation 1 and 2, like our original equations. If we subbed x equals 4 and y equals -2 to 1, we should get 6. And if we subbed it into 2, we should get 8 on the right-hand side. So sub x equals 4 and y equals -2 in 1. So left-hand side is 4 times 4 plus 5 times -2. So what's 16 minus 10? That's 6, which is right-hand side. So we're all happy. And then if we subbed x is 4 and y is -2 in equation 2, then your left-hand side is 3 lots of 4 and 2 lots of -2. So 12 minus 4 is 8, which is what we wanted on the right-hand side. So we now know that we have solved our x and y's unknown in the correct manner. I mean, you can also check with a graphics calculator if this is part of the tech